Okay, that takes us to section 2.3, and objective 1 says define organic chemistry and discuss the importance of carbon in living organisms. Well, organic chemistry is the chemistry of living things, of biological systems, and it's all about carbon. And the reason is because carbon interacts with a lot of other elements to make more complex molecules that make up living things. For instance, you can see in figure A the electron configuration of carbon, and in figure B, carbon interacts with those 4 hydrogen atoms and makes methane. So that's just one example of how carbon interacts with all these different elements. If we think of carbon like a tinker toy, now the little wooden piece that's carbon is marked with a C. In this case, it's kind of a light green. And if you remember Tinker Toys, you can stick in that carbon, that wooden carbon, you can stick in, there's 4 places to put in the little yellow bonds. So it can interact with up to 4 different elements. And the combinations, you can put single bonds there like you have with methane, where the carbon interacts with the 4 hydrogens, or it can be double bonds where the carbon interacts with 2 oxygens forming double bonds. So it's kind of like a Tinker Toy connector. And over there on the right you see glucose. You've got 6 carbons interacting with 12 hydrogens that are the blue ones, and then the oxygens are the red ones. There's 6 of those there. Now, we've said that they will, atoms will form bonds with each other to make them more stable, and the way they bond all has to do with how those electrons are configured. We learned earlier that the electrons sit in the electron shells around the nucleus, and those shells are just basically energy levels, and they are different distances from the nucleus. The first shell holds up to 2 electrons. If you have more than 2, you've got to go to the second shell. The second shell can hold, and the third and all the subsequent ones can hold up to 8 electrons. If they're full, they're going to be non-reactive. But if they're not full, then they're interested in bonding. You're looking at sodium on the left and chlorine on the right. You look at it. Sodium has 2 in the first shell and 8 in the second, and the third shell only has 1. Now look at chlorine. 2 in the first shell, 8 in the second shell, and 7 in the outer shell. So neither one of them have a full outer shell. So they're looking at bonding with each other to become more stable.